definition of linear equation and solving linear equations. I want to first start out by defining a linear equation. An equation in the variable x is a linear equation if it can be written in the form of are real numbers and a is not equal to 0. Let's just do an example. 2. This is a linear equation because it satisfies our definition. Notice our a is not equal to 0. And let's distinguish our a, b's, and c. Let's see, our a, our b is 5, and our c. What we should think about when we're distinguishing if something is a linear equation or not is let's look at the variable. Notice the power of my variable, the exponent here. 1. If we have an equation where all the variables have a power of 1, that would be a linear. Here will be an equation with the variable y. How about 5y plus 6 equals 3y minus 9. Now that doesn't look like our this is y, and the power is 1. Whenever I see an equation where the variables have a power of 1, let's try to get it in the form of ax plus b equals c. I move the 3 y's over here by subtracting those over. Remember, whatever I do to one side of the equation, I must do to the other side. 5y minus 3y, if we remember, we add the coefficients, we combine them. My b would be 6, and my c would be negative 9. In a linear equation, let's just take the one we just simplified last time. Two times that number plus 6 equals a negative 9. Solving linear equations are actually quite try to get the variable y all by itself on one side of the equal sign. Since the y's are already over here on the left, I'll just keep the y's over. Well, to do that, I'll subtract 6 from this side. If I subtract 6 from the left, I've got to also subtract 6 from the right. 6 and a negative 6 is nothing, they cancel. And I'm left with 2y equals negative 15. Two will do the inverse of multiplication. Divided by 2 is 1, so I get 1y equals negative 15 halves. Let's try one that involves the distributive property that you may have saw in a previous lecture. 3 times 2 minus 2x equals 5 times x minus 1. Equation. Well, remember, just look at the variable. Our variable is x, and let's determine the power of the exponent. The power is 1, so this must be a linear equation. Is 6. 3 times negative 2x is minus 6x. I'll do the same on the right. I'll distribute the 5 through this parenthesis. 5 times x is 5x. And 5 times negative 1 is negative 5. All right. Here is to solve for the variable x, which means I want to get all the x's on one side of the equation, everything else on the other side. How about if we move the 6x's over? Coefficients here of my like terms. Now, I want to get the x's on all by themselves. Oops. So I'll add 5 to both sides to get rid of that negative 5. To find our x value, I'll divide by 11. Now, one thing we should do is we should check our work. Let's go ahead and let's plug the 1 back into our original equation, and let's see if this becomes an equality. Let me go ahead and write the equation again. Remember, we said that x is equal to 1. Incidentally, some textbooks, instead of writing x equal 1, sometimes will some texts like to write it like this, some texts like to write it like this. So we said our solution was 1. Well, let's go ahead and plug a 1 back into our equation into all our x's and see if we actually get an equality. So wherever I see an x, I'm going to plug in my 1. So we want to check, does this equal? All right, let's fix the parentheses first. This is 2, multiply is minus 2. And I'll fix this parenthesis. 2 minus, and 3 times 0 is 0, which checks out. So we plugged our x back into the original equation, and we got an equality.